So in this question, they tell us the velocity of the particles. They're all to the right. Okay, all the velocities are to the right. And that's going to be the index finger of the right-hand rule, number 3. The magnetic field is the middle finger, and that's labeled as into the page. So then the thumb will be the direction of the force. And for particle A, the force is up. For particle C, the force is down. And for particle B, it goes straight through. There is no force. So therefore, particle B, I would say that is not, it has no charge. It has no charge. If it were charged, it would receive a force either up or down, but it doesn't. So there's no charge there. If I use the right-hand rule number 3, with my index finger pointing to the right and my middle finger pointing into the page, then my thumb points up. My thumb points up, and so that should be the direction of the force, which is where we see particle A go. So therefore, particle A satisfies the normal right-hand rule. Number 3. Which means it's a positive charge. Okay, the right-hand rule is built for positive charges. So since particle A satisfies the right-hand rule, it must be a positive charge. And finally, since particle C does not satisfy the right-hand rule, it goes in the exact opposite direction that the right-hand rule says it should go, it must be a negative charge. So that's how we answer this question.